Okay. Hi. Hello, guys. I'm just adjusting everything. Okay, I think that's fine. Let me get my chair sorted here. My pencil. Hi. Hello. Please share this live with everyone, guys. It's grade 10 to 12. We're going to be doing Trig for everyone. Hi. Hello. Thanks for joining. We're going to give it a few minutes, I think until 5 past. I'm quickly going to go make myself some coffee. Let me get some music going here on the PC. That is what we're doing. You guys can use the time also to get something to drink quickly. To please share the live. That would be amazing if you can do that. Let's see. Let me get some music going here. What shall I choose? What about, do you guys know Life at the website? It's so nice. I always play this music when I'm like working. It's very nice, just chilled. It has like different backgrounds. Let's see. Let's do Record Shop. What's that? So just put the music on. Okay, that's a bit of a jazz vibe. Okay, guys, we're gonna get started at 5 past. Please share so long. We're doing some trig, solution of triangles. This live will be suited to grade 10 to 12 learners. There will be something there for all of you. So please share and stay tuned if you are in any of those grades. I'm going to go make myself some coffee. I will be back just now. Okay, I'm back. Let's see who's here. Do I recognize anyone? Oh, thank you for sharing. Thank you so much. How was the first week back at school, guys? Are we glad to be back? I must say, I feel like the holiday was too short. It was just way too short for me. But yeah, it's part of life, I suppose. So how was the first week back? What grade are you guys in? Let me know in the comments. We'll get started in another 2 minutes or so. Grade 10, grade 11, okay. To else, this app is Good Notes on an iPad. Grade 10, grade 10. Okay, cool. Who else, guys? What grade are you guys in? Let me know so that I know who I'm speaking to. Grade 10. Is there a similar one for Samsung? I don't know. There are other note-taking apps. As far as I know, GoodNotes is only for Apple. But I haven't really done any research. Sorry. But if I see something, I will... yeah, I will post about it. I think I was gonna do a video, or I am planning on doing a video soon on like my favorite features of this app, because I've been using it for a little while now and I've gotten to know it a bit better. So yeah, it's a really cool app. Any notes for grade 12s? There are loads of notes on my Google Drive. If you click the link in my bio, it will take you there. Notes for grade 9 as well. There are notes for all grades on my Google not my Google Classroom. Sorry, my Google Drive. They are all saved on there. This app is GoodNotes, this one that I'm using. Okay, guys, it is 5 past. I think let's get started. There aren't really a lot of people here. Maybe people are busy. It is a Saturday, but I thought since I have the time, let me go live, and I will post it on my YouTube for anyone that's missing out. But guys, if you do have friends that might want to still join, please share this live. Only 2 people have shared it. It would mean a lot to me if some more of you can share it, especially if you have friends in grades 10 to 12. Yeah, I'm hoping that this live will be helpful for you guys and for whoever is in those grades. Okay, let me just take one sip of my coffee. Thank you so much, guys, for the shares now. That's awesome. Okay, so today we are talking about solution of triangles. I got an email from someone asking me, when do you use which rule? Okay, so if you are in grade 11 or 12, you will have already learned about the sine and the cosine rules. Those are rules that you use for non-right angle triangles, so we will chat about that. But yeah, this person was saying that they are actually a teacher and that their students are just finding the topic really difficult. They're struggling to recognize when to use which rules. So I will make shorter TikTok clips on that as well. But I just thought that it would be a good idea to do a live session on solution of triangles in general, because it is actually something that you start learning about in grade 10. Okay. Now, that is how maths works, guys. You learn something in a lower grade. In the following grade, you build on that. In the next grade, you build on that. And that is how it goes up until matric. And then at the end of matric, when you do your matric finals, you are not only tested on matric work. And a lot of people say you're tested on grade 11 and 12 work. But in fact, grade 11 work builds upon grade 10 work. And grade 10 work builds upon grade 9 work. And grade 9 work again builds upon grade 8 work. So it's actually really interesting in the different topics to see what you need to do in grade 10. Then in grade 11, you need to be able to still do that, but then something extra. So I thought that it was a good idea for me to actually just write down for you guys what the progression of this specific topic is. So in grade 10, right, when you are working with solution of triangles, you learn to just work with the trig ratios in right angle triangles only. Okay, you're only working in right angle triangles in grade 10. So that is the example down here that we're going to do. Then when you get to grade 11, you still need to be able to use the trig ratios. Now, guys, when I say the trig ratios, I'm talking about sine, cos, and tan. All right? Sine is opposite over hypotenuse. Let me make a little note on here. So when I'm talking about the trig ratios, I'm talking about, oh, sorry, that is actually not the correct thickness. All right? I'm talking about sine x, which is opposite over hypotenuse. Right? Then we have cos x, which is adjacent over hypotenuse. and we have tan x, which is opposite over adjacent. Now, I know in grade 10 you do the reciprocals as well. You do cosec, sec, and cot. But guys, you don't actually get tested on those again in grade 11 and 12. So, yeah, we're not really going to focus on that too much. Obviously, you do need to know those for grade 10, but we're going to focus on how this is now progressing going forward. All right, so in grade 10, you just need to be able to work with those trig ratios in right angle triangles. Then in grade 11, you still need to be able to use the trig ratios in right angle triangles, but in combination with that, you need to be able to use the sine, cosine, and area rule, which we will go over today, to solve non-right angle triangles. Right? Sine, cos, and tan, those three ratios you can only use in right angle triangles. So when you're working in non-right angle triangles, you actually need to use the sine rule, the cosine rule, and the area rule if they're asking for area. Now guys, in grade 11, you do all of this stuff in 2 dimensions. So it's a flat diagram. All right. Then in grade 12, you still need to be able to do both of these that you have to do in grade 11. So you need to be able to work in right angle triangles and non-right angle triangles. But now in grade 12, you need to be able to apply that to 3-dimensional problems. All right. So that is how the topic actually progresses through the 3 senior grades. All right, so we are going to start off by doing a grade 10 question. Now, this is a grade 10 question from an exemplar question, actually, that I found online from the Eastern Cape, a grade 10 exemplar question. It's not a very difficult one. I just wanted to remind you guys of how it works, how you use sine, cos, or tan in a right angle triangle to solve that triangle. Now, just to clarify, when I'm talking about solution of triangles, you can either be asked to find the length of a side or to find the size of an angle. All right, so we need to be able to do both of those things. In this case, 3.5, they are saying, without using a calculator, that's interesting, we'll talk about that now, determine the value of x in the diagram below. Okay, now guys, x in this diagram is a side. So they are wanting us to find the length of that side. Now, as you can see, this is a right angle triangle, so we are going to have to decide whether we are going to use sine or cos or tan. Now, I'm sure you guys have seen this SOHCAHTOA. It's a way of remembering what the 3 trig ratios actually are. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so these are the 3. We need to decide which one we're going to use. Now let's look at the angle that they've given us. They've given us that angle, which is 30 degrees. The side that we are trying to find, right, x, that is the opposite side. Okay, so we are going to have to work with opposite because that's the side that we're trying to find. The side that they have given us, right, the length that we actually have is this side, AC, which is opposite the 90-degree angle, so that is the hypotenuse. All right, so we have a 30-degree angle, we're trying to find the opposite side, and we have the hypotenuse. Now, which trig ratio works with opposite and hypotenuse? It's sine, right? Sine works with opposite and hypotenuse. So we are going to use sine in this triangle to solve for x. All right, that is how you decide which trig ratio you're going to work with. So we are going to say, I'm actually going to try and squeeze it in here on the side. We're going to say sine of 30 degrees is equal to, remember, sine is opposite over hypotenuse. So x over 1,250. Okay, that is now actually setting up our whole equation. All right, sine 30 is x over 1,250. Now, guys, when you want to get x on its own now, right, that's what we want to solve for. We're solving for x. On this side, you are dividing by 1,250. So when we are now solving for x, we want to get rid of that 1,250. The opposite of dividing by it will be multiplying by it. Okay, so we're going to say that x is actually going to be equal to 1,250 multiplied by sine 30. You don't have to write the time symbol there. Okay, you can actually just write 1/250 sine 30. Yes, could times by 1/250 on the other side, correct? So now, guys, they said without the use of a calculator, right? That's what they said in the instructions, without using a calculator. Now, when you are working with sine 30, you are supposed to know your special triangle off by heart. I'm just going to draw it here on the side. All right, so you are then supposed to show your 30-degree triangle. If they say without the use of a calculator, they do want to see that triangle. That is like you proving that you didn't use your calculator. Okay, let me just make this a bit thinner. So we have our 30-degree angle, and we have our 60-degree angle, and then you are supposed to know this off by heart, guys. So please, you have to memorize the sides of this triangle. We have 1, 2, and √3. I always draw mine with this orientation, with the 30 at the bottom and the 60 at the top. You can draw it the other way around, okay? But then your sides will also be, these two sides will also be the other way around. Okay, but it's fine. It doesn't matter. Either way is fine. All right, so now we need to use this triangle. We're not allowed to use our calculator to get sine 30. We have to use this triangle to get the value of sine 30. So there we have 30 degrees. Sine, remember, is opposite over hypotenuse. So sine 30 is a half. Okay, so here we're going to say that this is now equal to 1,250 multiplied by a half. Now, guys, a half of 1,250 is, does anyone know what that is? 625. Let's see, what was this? They didn't, kilometers. Okay, so the unit that we're working in here is kilometers. All right, 625. Let's see some questions. If I don't remember, I put it in a calculator and draw the triangle correctly and show the angle. The triangle, rationalize the fraction. That's fine. You can rationalize the fraction. Just make sure that you have those values on your triangle then. Okay, because if they asked you to find, for example, tan 30, it would be 1/√3. So if your fraction is rationalized, but you have 1/√3 on the triangle, you're not going to get that mark. Okay, so it's better to not rationalize the fraction from the start. Let me just see, there were some other questions. Do teachers learn very complex geometry at university, or why are you so good? Yeah, it depends on what you study. So not all teachers study the same thing. I studied a B.Ed. I have made some videos on your options when you want to become a teacher, and also how I ended up being a teacher. So you can go look at that. For my course, we didn't actually do a lot of geometry. We were more focused on calculus and algebra stuff, but we did quite a lot of trig, I must say. And I think because of that, I'm very confident in trig. But for geometry, you just have to practice. And I think that's why teachers are good, because we do it every year over and over again. So yeah, the more you practice, the more, the easier it becomes. And you do start recognizing things quickly if you've practiced a lot. Okay, guys, so that is the kind of thing that you need to be able to do in grade 10. All right, in a right angle triangle, you need to be able to use sine, cos, or tan to solve for a side or for an angle. Okay, now in grade 11, it gets a bit more complicated, because now if we're looking at this example that I have here, they're saying in the diagram, and this again is from a grade 11 external final exam. I'm not sure if you guys write external exams in grade 11 already, but some schools do. So you can find those papers online if you're looking for more practice. So here, guys, if we look at these two triangles, we will be able to see that they are not right angle triangles. Okay, so if you're in grade 10, you wouldn't have done sine, cos, or area rule yet, but you can just, listen to this and then you'll be ahead of the pack next year. So they're saying in the diagram, A, C, E, and B are the vertices of a quadrilateral. Angle ABC is 31 degrees. Angle BAC is 106. Angle BCE, there we go, is 46 degrees. At side AC is 4,6. CE is 10, and BC is X. Okay, it's a very good idea, guys, that whenever you What was I going to say now? Sure, I just lost my train of thought. Oh, whenever you're starting with a question like this, for trig or for any kind of geometry, read through the information that's given, because often there's some information that's written down here that's not on the picture. Okay, so it is very important that you actually read through all the information just to make sure that you have everything on your picture to work with. And guys, another tip that I can give you is when you are calculating something, fill it in on your diagram, because usually like 7.2 will follow on from 7.1. Okay, you'll have to use your answer in the next question. All right, so calculate the length of BC. That is the first question. All right, we need to calculate this length of BC. Now we need to look at the fact that we have two triangles here, guys. In this triangle, we have quite a lot of information, right? We have an angle there. We actually have two angles, so we can find the third one if we need it. We have a side there, and we're looking for side x. In the other triangle, we don't have as much information. Okay, so we do kind of have to compare, and we need to figure out which triangle has more information. All right, so this triangle definitely has more information than this one, because in this triangle, we only have one angle and one side. Here we have two angles and a side. Now, guys, when we are working in a non-right angle triangle, we can't use sine, cos, or tan. We cannot use those trig ratios. We have to use sine rule or cosine rule. Now, what I usually look for is I first check whether I can use sine rule. Okay, now in order to use sine rule, I'll write it here at the bottom. We're trying to find a side, right? So sine rule always works with, if we're trying to find BC, so I'm not going to fill in the values yet. I'm just going to do it in general form. So BC, according to sine rule, we then have to put that over sine of the opposite angle to BC. Now, the angle that's opposite BC is angle A, right? That is then equal to any other side in this triangle. Now, which other side do we actually have in this triangle? AC. That's another side that they gave us, AC. Again, over sine of the opposite angle. So if we're looking at AC, the angle that's opposite that side is angle B, angle ABC. All right, so ABC. I'm not going to write just B because there are two angles there at B. All right. So guys, this is how sine rule works. Oh, my apologies. If you're looking for a side, you need to put that side over sine of the opposite angle, and then you need another pair of a side and an angle that are opposite each other, and that will then be equal to your first fraction. So here we have AC. We'll have to put that over sine of the angle that's opposite AC. Okay, now luckily in this case, we have all of that information. We have angle A, we have side AC, we have angle ABC. Sometimes you won't have all of it and you'll have to calculate some of it, all right? But we can talk about that later. Actually, I'm not going to erase that. So here underneath the actual question, I'm going to do the calculation. All right, so BC over sine. Now again, BC, actually I shouldn't say BC. Hey, I should actually just say X because that is what BC is. So let me just change that to X. All right, they're asking us to find the length of BC. So I suppose it would have been fine if you kept it as BC, but BC is also X. All right, so this BC over sine of the angle that's opposite that side is 106. Sorry, I'm just trying to lengthen that line quickly. And that is then equal to another pair of a side and an opposite angle. So 4,6 over sine of 31. All right, so that is what we are putting in. Now, guys, you haven't even calculated anything, but you will already get a mark for doing that. Okay, just for setting up your sine rule, you get a mark. Someone's asking what grade this is for. This specific question is a grade 11 question, but you do need to be able to do this in grade 12 as well. All right, now guys, we need to solve for x, okay? We need to get x on its own. So here we are dividing by sine of 106. The opposite of dividing by sine of 106 is multiplying by sine 106. So that is what we're going to have to do on the other side. So we're going to say that x is equal to, now I'm going to write it in one way, and then I'm going to show you a better way of writing it actually. So I'm just going to say this fraction that we have on the other side already times sine of 106, right? But it's actually better, and I'm sure that you guys have seen this before. I hope that we agree that this is the same as sine 106 over 1. So we can actually, instead of having a fraction multiplied by a separate thing, we can write this all as one fraction. Okay, so we can actually say that this is 4,6 sine 106 over sine 31. Let me just move this next picture down a bit. All right, now all that's left, guys, is we need to actually type this into the calculator. Okay, so I'm just going to type this in. Someone's asking if you need a reason for the fraction. You don't. You are actually just using a formula. You're using sine rule, so you don't need a reason for that. Okay, the answer here, I've typed it into the calculator, is 8,59 centimeters. All right, so that is the answer there. Now, like I said, we've calculated something, so now I'm actually going to fill it in on my diagram, 8,59 centimeters. Okay, so that's the answer there, guys. That is how sine rule works. Okay, 7.1.2 is an interesting question, and it is a question that actually gets asked very often in matric finals, is where they give you a shape and you need to find the area of that shape. And usually the shape consists of multiple shapes that have been put together. Okay, so that's what they're asking us in 7.1.2. They're saying calculate the area of quadrilateral ACEB. Now, ACEB, that is the whole shape that we need to find the area of. Now, guys, this whole shape consists of two non-right angled triangles. The only way in which we can find non-right angled triangles, all right, in which we can find the area of non-right angled triangles is if we have the perpendicular height, right? So if they had put in, for example, a line like that, and they said, okay, that's the perpendicular height, and they gave us a length there, then we could calculate that area using our half base times perpendicular height formula. All right, in this case, they haven't given us either one of these two triangles perpendicular heights. So that means that we need to use area rule to find the area of these two triangles and add them together. All right, so area rule is saying that you are going to take half AB times sine of C. Now what this means is A and B are two sides of the triangle, and then angle C is the included angle, the angle in between the two sides that you've used. All right, so we're going to look at the two triangles that we have now, and we're going to try and identify whether we have enough information to actually find the areas of both of these triangles right from the start. Now, if we're looking at this triangle ABC, okay, we have two angles there. Now, guys, again, when you're using area rule, you need two sides and the included angle. So it's better to actually look at the sides that we have. We have this side, we have AC, right? And we have BC. We have those two lengths. Now, that means that we need the included angle. We need the size of the angle in between those two sides. Then I can use that to find the area. Now, at the moment, I don't have that angle. All right, so I'm going to have to calculate that angle first. So let's do that. Angle ACB, I'm actually going to do it underneath this picture. Angle ACB is going to be 180 minus 31 minus 106 degrees. For this, you do need a reason. You need to say angle sum in triangle. I'm lazy to work that out in my head now, so let me just type that in. Don't judge me. Okay, that answer is 43 degrees. Okay, so that is 43 degrees. So that is the angle there. So guys, with that information, with this side and the included angle, we can find the area of that triangle. Now let's look at the area of the next triangle. We also have two sides in this triangle, right? We have, I'm going to use a different color highlighter. Let's use purple. We have this side, which is also a side of the second triangle. And then we have 10 centimeters there. And we do have the size of the included angle. It's 46 degrees. Okay, so for this triangle, the second one, we actually already have all the information that we need in order to find the area of that triangle. Okay, now guys, I suggest that instead of working out this area separately and then that area separately and then adding them together, let's rather work on doing all our calculations in one line. Okay, so I'm going to write it like this. I'm going to say area of ACEB, right, the whole shape, the whole quadrilateral, is equal to the area of triangle ABC, the blue triangle on the side, plus the area of triangle BCE, that one on that side. Okay, now I'm going to do the calculations of both of them at the same time instead of doing separate calculations and then adding them together. Okay, it's more time efficient to actually do the calculations at the same time. So like we said here, the formula is half, right? Then you take the two sides that you have. So we have 4,6 times 8,59 times sine of the included angle, the angle in between them, 43 degrees, plus, right, so that will give us the area of the first triangle. Schoolwork on Saturday, yeah, sometimes it's necessary. Then a half, so the second one, a half, the two sides that we have multiplied by sine of the included angle. So it's 8,59. Sorry, there's a baby crying outside. I don't know if you guys can hear that. It's not my baby, actually, for a change. Times sine of 46. All right, so now instead of doing two separate calculations and adding them together, we've written out one long calculation, and we're now going to type that in. Okay, so I'm just going to do that quickly. 4,6 times 8,59, and then sine, okay, and then plus, and then we're doing the other one, and then sine of 46, and then my final answer is 44,37. And now because this is area, we need to remember that we're doing centimeters squared. I teach grades 8 to 12. I don't teach grade 9 this year, but I have taught grade 9 all other years. It's just, yeah, every year there's one grade that we don't teach. So last year I didn't teach grade 10, for example. This year I don't teach grade 9, but I have taught all of them before. Okay, so that is a typical grade 11 exam type question. All right. When will grade 12 session take place? I'm going to do a grade 12 example right now. Okay, that is the next thing that I'm doing. Guys, are there any questions on this specific example or grade 11 sine, cos, and area rule before we move on to the grade 12 question? I'm just going to give you a chance to get any questions out of the way, and I'm going to take a sip of my coffee here because I've been talking the whole time. Okay, no questions. All right. Let's move on to the grade 12 example. Now, this question is from, I think, the 2018 final exam paper, question 7, as you can see, and this is a 3D question. Now, guys, the 3D questions, yeah, sometimes they're quite tricky. Sometimes they use the matric question paper. Sometimes the problem solving question is the 3D question. So I didn't choose a problem solving question for this session now because I just want us to get the basics down. I am going to go live again tomorrow. We can do some more trig, maybe some other trig as well if you guys prefer. But this was one that isn't too hectic. Okay, there still are some difficult things to this question, but it was just 6 marks, and it was the only 3D trig question in this whole exam, only 6 marks. Okay, so that's not a lot. So they're saying, let's just read through the whole, what's this called, introduction here, and then we'll see if everything is actually indicated on the picture before we start answering the questions. So So they're saying a pilot is flying in a helicopter, that thing there, all right, at point A, which is h meters directly above point D on the ground. Okay, so they're saying that AD essentially is h. That's what they're saying. He notices a strange object at point B. Okay, so this guy is in the helicopter and he looks down and he sees a strange object at point B. The pilot determines that the angle of depression from A to B is 30 degrees. So they have indicated that there. All right. Now, guys, something that they'll never indicate on these diagrams, but that we do have to know and have to use, is that when they've given you the angle of depression, right, and they've drawn that line there, this line is always parallel to the line on the ground. That is very important. Not a lot of people, or I should rather say a lot of people forget that, all right? And it's also not indicated on the picture, and they also won't tell us that. Okay, so I'm going to say again, if they've given you the angle of depression, and this applies to grade 10 stuff as well. Even in grade 10, they can give you the angle of depression, and you then need to know that the line that is forming that angle of depression at the top is parallel to the line at the bottom. Okay. He also determines that the control room at point C, okay, so at point C there we have a control room, is 3h meters from A. All right, so that distance there is 3h. They've indicated that. And angle BAC is equal to 2x. Angle BAC, so that angle at the top there is equal to 2x. Now, guys, the thing about this angle here, I think a lot of people get confused. When you are looking at this picture, okay, this shaded area, they are saying that in the next sentence, points B, C, and D are in the same horizontal plane. The horizontal plane is the ground, okay? So I'm literally going to write on here, this triangle is on the ground. So you almost need to imagine that they have drawn a triangle on the ground, all right? And this shaded triangle is that triangle. This triangle, remember this guy is in a helicopter, all right? This is the distance from the helicopter to the ground is h. Now, they have indicated there that it's perpendicular, but they might not, okay? But that is important, okay? Queen, thank you. Okay, now, this, guys, we need to try and visualize this. It is quite difficult. We have a triangle on the side. This triangle is standing up. This triangle is on the ground. This triangle is standing up. This triangle is also standing up. They're almost like that, and then we have the triangle on the ground, right, which is triangle BCD. Okay, so that's important. I hope that you guys can visualize that. But then we have a third, or actually a fourth triangle, right? We have this one on the side, we have this one on this side, we have the triangle on the ground, then we have a third triangle that is going from point A, which is here where my finger is, I suppose, right? Point A, the helicopter, from point A, kind of skew down to the front side of the triangle on the ground. I hope that makes sense. All right, so we have these two triangles that are standing up. The helicopter guy is here at the top at my finger. We have triangle BCD on the ground. Then we have a fourth triangle that's going from point A down, and it's meeting BC. Now, when they're saying angle BAC is 2x, that is an angle on this front triangle. All right, that is not an angle on either of these upright triangles. Okay, and that is what makes 3D trig so difficult. It's really difficult to visualize. Okay, I'm actually going to build a model. I'm going to do it this week. It's on my to-do list. I'm going to build a model, and I might even use this example so that you guys can see. I'm going to actually build a model of this 3D trig scenario, so that maybe if you see like an actual model of like a triangle standing up, a triangle standing upright, another triangle standing upright, a triangle on the ground, and then a triangle going forward, kind of skew, then maybe you will be able to visualize those a bit easier. Okay, I am currently teaching my matrics this section, and yeah, I think they will also really benefit from seeing it like in real life. Okay, so this angle BAC is on that front triangle. We need to remember that. Okay, let's see what else. The scenario is shown in the diagram below. Okay, 7.1, the question is, determine the distance AB in terms of h. Now let's see, where is AB? AB is that side over there. I'm going to highlight it. It's quite nice if you are able to highlight what you need to find. Okay, so we need to find this angle, or this side, sorry, AB in terms of h. Now guys, AB is a side of a right angle triangle. Remember, this is the triangle that's standing upright, okay? So AB is a side in a right angle triangle. Now, if we have a right angle triangle, we can use sine, cos, or tan. We don't always have to use sine rule or cosine rule, guys. I suggest that if you have a right angle triangle, use your trig ratios. We can do the same thing here, right? In both of these. Use sine or cos or tan. It's actually much quicker than sine rule or cosine rule. Okay. Now, in order to use a trig ratio, we do need an angle though. An angle that's not the 90-degree angle. We either need this angle over here or we need that angle over there. Now guys, the fact that we have parallel lines over here. Do we see the Z shape? Sorry, it's a bit skew, but do we see that Z shape over there? That Z shape is going to allow us to say that angle ABD is actually a 30-degree angle because of, sorry, let me just fix this here. Angle ABD is actually a 30-degree angle because of alternate angles, the Z shape, right? And that those parallel lines over there. Yes, someone's saying 60 degrees. You can use that 60-degree angle there as well. That's perfect. Yes, BAD is 60 as well. Okay, I'm going to do this 30-degree angle because I do want us to use these parallel lines. Okay, just so that we are reminded of the fact that if we have parallel lines, we're probably going to have to use it. Okay, so that's what I'm going to write down first. I'm going to say ABD is 30 degrees, and my reason is parallel lines, alternate angles. So ABD is equal to 30 degrees, but if you want to work with the 60-degree angle, that is also perfectly fine. Alternate angles, and let's see. Now, this line here, guys, wasn't wasn't labeled. We just have an A. So now we know that that's BD and that's A, but this wasn't given a letter. So we can't actually say anything. We can't say like something A is parallel to BD. So we're just going to have to say parallel lines. Okay. If you don't know the names of the two parallel lines, then you just write parallel lines. That's perfectly fine. Do I answer the chat? Yes. Solve for H. I'm not sure if they're going to ask us to solve for H. They're not actually going to ask us to solve for H. Okay, so we have that 30-degree angle. Now, guys, remember we're trying to get AB. All right? I'm actually just going to erase this quickly because it's getting a bit full. And then I'm just going to put that 30-degree angle back in there. That is 30. Those two lines are parallel, and we are finding AB. Okay, now that we have that 30-degree angle, and they're saying in terms of H. Do I remember Mr. Marie? Yes, I do. Do I know you? Were you at my school? Yeah, Mr. Marie and I are friends, I would say. We're still in contact often about maths in general. I actually tutor one of his students at the moment. What level is grade 12 in like Balkan countries? I have no idea. Sorry, I'm not very clued up on other countries' curriculum. Okay, so guys, we have 30 degrees. We're trying to find AB, which is the hypotenuse, right? I'm working in this triangle now. 30 degrees, AB is the hypotenuse, and H, they said we must give in terms of H. Oh, you told him about my page. Cool, did he say that he knows me? When you see him on Monday, tell him that I said hi. All right, so 30 degrees, the opposite side is H. All right, so we have the opposite side, H, and we are finding the hypotenuse. Now again, which trig ratio works with opposite and hypotenuse? That's sine, right? Which trig ratio works with opposite and hypotenuse? That's sine. So we're going to say sine of 30 is equal to H over AB. And this is similar to, if you were here earlier, what we did in the grade 10 question. Okay, so sine of 30 is equal to h over AB. So do you see now, guys, that when you are doing a grade 12 question, you still need to be able to do grade 10 work. All right, and that's what I want you to understand with this. So now we need to find AB. They're asking for AB in terms of h. So this AB needs to go over to the other side. Okay, we can't have it in the denominator. So AB sine 30 is equal to h. All right. So AB sine 30, do we know what that is? It's a half, hey. AB sine 30 is a half. That is equal to h. Now, guys, if we want to get AB on its own, SOHCAHTOA, yes, that is correct. If we want to get AB on its own, I need to get rid of this half. Now, on this side, I'm multiplying by a half. The opposite of multiplying by a half when I move it is dividing by a half. Now, when you have h divided by a half, right? What do we do when we divide by a fraction? We tip and times. So this is actually going to become h times 2 over 1, which is in fact 2h. All right, so we have now determined the distance AB in terms of h. Guys, they're not telling us find the value of h. Not at all. They're saying in terms of h. That means that the answer has to have an h in it. Okay, that's what we've done here. So AB now, I'm actually going to put that in. Let me just again erase this highlighted bit because we're actually done. We have now found AB in terms of h. AB is 2h. Okay, perfect. Now, the next question, 7.2. This is a 4-mark question. The first one was actually just 2 marks. Okay, this one is now 4 marks. So this is now the more difficult question. Show that the distance between the strange object at point B and the control room at point C is given by this expression. Okay, so now we need to start doing some hectic stuff here. Someone's asking, where can you find more videos? There are lots of videos on my YouTube, also on my TikTok. I post daily, but I have lots of videos on my YouTube. The link is in my bio if you want to find my YouTube. Okay, so now we need to find BC. Okay, they're telling us what BC is. So we need to find BC, and then whatever we're working with, we need to manipulate, we need to work on, we need to change so that we get it into this form. Okay, so BC is now the one that we're finding in this question. Now, guys, I want to remind us of this triangle in the front, right? The triangle in the front. We have this triangle standing up, that triangle standing up, the triangle on the ground, which is the shaded one, and then we have the triangle in the front. Now, BC is a side of the triangle on the ground, yes, but also the triangle in the front. And the reason why I'm saying that is because we now have that side of the triangle on the front, right? We have 2h. We have 3h, which is the other triangle, or the other side, sorry, of the triangle in the front. And we have 2x. Now, guys, if you are trying to find a side of a triangle and you have the other two sides and the included angle, you can use cos rule. And we are supposed to get cos x here, right? In the thing that we're proving, there's actually cos squared x, but we're supposed to get cos x there. So I am going to work with cos rule. Okay, let's see if that works. I'm not sure. We're going to try it out, but yeah, it probably will. Okay, so we're going to say, if you guys don't remember how cos rule works, I'll write it out for you. BC squared, the side that you're trying to find, squared, is equal to the other side squared, so AB squared, plus the third side squared, AC squared, minus 2 times those two sides, so AB and AC, times cos of the included angle, which is BAC. So basically the angle that's opposite the side that we're trying to find. Okay, let me just see, is that on the screen? There we go. So that is how cos rule works. All right. Again, guys, the reason why I'm using cos rule is because I have the other two sides and the opposite angle. All right. And that is a surefire way to know that you need to actually use cos rule, but also because the thing that I'm trying to prove has a cos in it. All right. So that is another clue. That's why I know that I need to use cos rule. Okay. So now let's actually fill in the values that we have. AB was 2h. So in brackets, 2h squared plus AC is 3h. So 3h squared minus 2 times 2h times 3h. So those same two sides, we're just multiplying together, times cos of the included angle, which is now 2x. Now, guys, cos 2x, we're going to have to use a double angle identity. Okay, and for cos, there are 3, so we're going to have to decide which one to use. I'll show you just now how we're going to decide that. First, I just want to simplify this because we have a lot of brackets and stuff going on. So let's first just simplify this. 2h all squared is 4h squared plus 3h all squared is 9h squared minus, now when we multiply all of these together, we have 2 times 2, which is 4, times 3, which is 12. We have an h and an h, that's h squared, and we have cos 2x. Now, guys, all of this is equal to BC squared, so we are still going to have to do the whole square root thing, right? Which is also what we see we're working with, what they're asking us to prove. I'm not going to do that yet, okay? I'm going to keep that up until the end. But let's take a look now. We need to decide which double angle identity are we going to change cos 2x into. Now, guys, in order to make that decision, you have to look at what they're asking you to prove, because there are 3 double angle identities for cos, all right? I'm going to write it here on the side. Cos 2x. The first one is cos squared x minus sine squared x. Now, guys, if I'm looking at what I'm trying to prove here, there is no sine. There's no sign in this whole expression, so I'm not going to do that. I'm not going to choose this one, because why would I introduce a sine squared if I'm not actually looking for a sine squared? All right. The other one, the second one, is 1 minus 2 sine squared x. All right, that is the second double angle identity for cos 2x. But again, guys, if I'm not looking for a sine, there's no sine in here. Why would I introduce a sine squared if I don't want a sine squared in my final answer? So the other one, right, the third one is 2 cos squared x minus 1. That is the third double angle identity for cos. Let me just actually make 100% sure. Cos is 1 minus, yes, okay, that is correct. Okay, so this is 2 cos squared x minus 1. Now, guys, if we're looking at these 3 options, obviously we're going to choose the one with only cos squared x, because if we're looking at what we're trying to prove, there is only a cos squared x in there. Okay, there's no sine squared x. So that's going to be the next step. I'm going to replace cos 2x with this double angle identity, 2 cos squared x minus 1. Okay, what I can also do is, these are like terms, so I'm actually going to add them together. 4h squared plus 9h squared is 13h squared. Then we have minus 12h squared. And then cos 2x, I'm going to change that to 2 cos squared x minus 1. All right, next up, we're going to have to multiply that 12h squared into that bracket. So we have 13h squared minus 12 times 2 is 24h squared cos squared x. All right, that's what I get when I multiply 12h squared by the first term, and now I must multiply negative 12h squared by negative 1. That's going to give me positive 12h squared. Okay, things are starting to take shape, guys. We're getting closer and closer to what we're trying to prove. Now, if I look for like terms, 13h squared plus 12h squared is 25h squared. All right, minus 24h squared cos squared x. Now guys, hopefully we notice that we have an h squared in both of these terms. So I'm actually also going to take that out as a common factor. All right, that will be a good thing to do for going forward. So I'm going to take out h squared as a common factor. I'm left with 25 from my first term minus 24 cos squared x. Guys, we are so close to what we are supposed to prove. Look at what we're supposed to prove. We're supposed to prove that BC is h times the square root of 25 minus 24 cos squared x. Do you guys see how close we are, right? This is BC squared. If we want to get BC, I must just take the square root of this whole thing, and then that is the answer. That's what they asked us to prove. So therefore, BC is equal to the square root of this whole expression. I'm lazy, so I'm actually gonna just copy it. All right, copy. And now there's dog barking outside. Sorry about that. There we go. The square root of this whole thing. Let me just close that square root. There we go. Now guys, h squared does have a square root, right? The square root of h squared is h. And then we are left with the square root of this expression, which doesn't have a square root. So we're going to have to leave it in that root. And that is exactly what they asked us to prove. Okay, all done. Yes, copy and paste, isn't it nice? All right, guys, that is it. So that was a 4-mark question. I don't have the memo in front of me, but I'm assuming that you would get a mark for putting everything into cos rule. Then maybe a mark for simplifying it. You would definitely get a mark for changing cos 2x to the correct double angle identity. That will be the second mark. Then I think you'll get your third mark either for getting to that step or that step, all right, for actually multiplying everything out and simplifying it. So for one of those two, and then the fourth mark would be for actually taking the square root, because you have BC squared, so then you have to square root that. I think that's what it would be, those 4 marks. Okay, so yeah, I don't think that one was too bad, but guys, you did have to understand the whole concept that we spoke about of the triangle in front, which you can't actually see. Okay, so that is what made this question a bit more difficult, is that we were working in this front triangle with those two sides, side BC and that included angle. All right, let me see. In grade 12, are we required to know the proofs of sine, cos, and area rule for final exam? Yes, you are. You are required to know them. Yes. Let's see. Did I miss any other? Yeah, so 25 has a square root. But guys, remember in grade 11, I'm not sure what grade you are in, but in grade 11, you learn that you can't separate terms in a square root, right? So if you're taking here, do we see that these are 2 terms? You can't say that since 25 has a square root here, you're going to say that it's 5. Okay, you can only do that if you have 1 term. So in the previous line, we have 1 term, and 1 factor of that term has a square root. Okay, so that's what I did there. But here we have 2 terms. So you can't actually separate the 2 terms and take the square root of the 1. Okay, but that is a very common mistake. So thank you for asking that question. Let me just go back up quickly to see. I'm good, thank you. Oh, Ntombi, you are lost. Where did I lose you? Let me know. Let's see. Did you join late maybe? Maybe you didn't hear the first bit. GCSE. Who was talking about GCSEs here? Oh, no, this isn't GCSE, but I think you do need to know this in GCSE. So, guys, yeah, maths is a bit of a... it's difficult to explain because... Or not difficult to explain, but I suppose it's complicated in the sense that maths is maths, right? Like whether you're doing maths in South Africa or you're doing maths in the United States or you're doing maths in the UK, trig is trig. It's just the grades that are different. So when I'm saying on my videos, like this is information for grade 10, I am talking about specifically South African grade 10 syllabus because I am South African. I teach in a South African school, but like I said, maths is math. So even if you are in the UK or you are in the US or you are in Australia or in Brazil or wherever, if you have to do trig, then you can learn from my videos. Okay, let's see. Yeah, I think I have answered most of these questions. Let me just go back down. I see there are 8 new messages. Guys, what I'm going to do is right now I'm going to post this note onto my Google Drive. So if you, oh dear, what happened there? If you click the link in my bio and you go to, where will I put it? It's not for a specific grade. I'll put it under TikTok live notes, and then you can find it there. When is the next live? So I'm going to go live again tomorrow at 5. Please join. I haven't decided what I'm doing yet. My education level, what did I graduate in? I did a Bachelor of Education for Further Education and Training, which is grade 10 to 12. My majors were maths and accounting, and I graduated top of my class, cum laude. Where was I? What do you mean? Oh, and Tombi, yeah, you joined late. Yes, so then you will be you will be confused. If you missed the first bit, I'm going to post a recording of this live on my YouTube. Hopefully, I will be able to still get it up tonight. But otherwise, I will do it tomorrow, and then you can go watch the whole thing there. It's better if you actually watch the whole thing. Okay. Yeah, it will be on the YouTube channel. We do use the CAP syllabus, yes. I teach at a public school, but we were actually just named yesterday. We came first in the country for quintile 5 schools based on last year's matric exam results. So we're very, very proud of that. So yeah, I suppose I can say I work at the best public school in the country, which is really nice. Okay, when do I do grade 12 maths? So I try and do lives for like all senior grades at the same time. So I'm not going to do like just a grade 10 specific live. I'm going to do this kind of thing, which if you joined late, you wouldn't have seen my first explanation where I was showing like solution of triangles, how it progresses. Okay, because all the time when we are in grade 10 and in grade 11, we are working towards grade 12. So I think there were some people on here now that are even in grade 10 that stayed all the way up until grade 12 questions. And I think it was good for you. You got a bit of a head start. So yeah, whenever I do go live, I will go live either for grade 8 and 9 together or for 10, 11, and 12 together. But I am going live again tomorrow at 5. So if you can just find one of my videos on my TikTok and just comment what you want me to go live on, and I'll see if there's something that a lot of people are requesting. Otherwise, yeah, I'll just choose something from what you guys are asking for. Geometry. Oh, accounting. I haven't taught accounting in a very long time. I actually can't remember much, I must admit. I miss it very much, but I just can't remember. What software am I using? So this is an iPad and I'm using Good Notes. That's the name of the app. 2019 Maths Paper 1. Okay, noted. I'll see if I can do some videos on that. Trig equations. I think I have done a live on that already earlier. So you can go take a look. It is on my YouTube. But yeah, like I said, just go to any of my recent TikTok videos and just comment what you want me to go live on, and then I'll see if multiple people are asking for the same topic, then I'll do that. Help with accounting. Yeah, sorry guys, I'm not gonna say that I am able to help because I might help you from the frying pan into the fire. I really can't actually remember. I did really well in accounting. I got like 90s and stuff, even at university. I really enjoyed it a lot. I think it's such a cool subject. I just haven't done it in very long. And yeah, whenever you just don't practice something, you do eventually lose it. So yeah, I've been focusing on maths basically for my entire teaching career. In my first year of teaching, I taught grade 8 and 9 EMS, but I haven't taught senior accounting since my prac year, which was 10 years ago. So yeah, it has literally been 10 years since I taught accounting. Okay, you need help with probability. Okay, noted. Yeah, probability is quite tough. Okay, let's see. All right, guys, so I think I'm going to call it here. Are there any other questions? How am I such a pro in maths? I've been doing this for a long time and I'm passionate about maths. I do enjoy it. And I've been working with quite a lot of kids that struggle a lot. So I think I've gotten quite good at making difficult concepts quite simple. I don't want to brag, but I do think that I am able to do that. YouTube name, it's Miss Hanekom. It's Hanekom. That's my surname. You can just search there, Miss Hanekom. Yes, I know you love maths. I must say, thank you so much for always being so supportive on all my videos. I do really appreciate your comments, even though I don't always reply. I don't know, I don't always get notifications when people actually comment on my videos. So sometimes I'll just like go through my recent videos and I'll scroll through the comments and then I'll see comments that I didn't know were there. So please, I don't want anyone to think that I am ignoring you. I do see your comments, not all of them, but it's not by it's not by choice. All right, thank you so much, guys, for joining. I know it's a Saturday evening, 6 o'clock now. I'm gonna go spend some time with my family. I will see you again tomorrow at 5. Please join. Let your friends know and comment on my videos what you want me to go live on. But if you follow me, then you will get notified whenever I do go live, even if you miss an announcement. So please do follow and share my stuff with anyone that you think can benefit from it. Thank you so much, guys. Do your maths homework. Yes, good luck with that. Hello, Michaelo. I see you are also here. You also always comment on my stuff. Cool. Thank you so much, guys. I had fun doing this. I hope you learned something. And I will see you tomorrow at 5. Have a good evening. Bye. Ooh. And there we go.